Welcome to Studio K, a game design curriculum for computational thinking. First of all, why a curriculum based on game design? Well, as many of you may be aware, video games are immensely popular with kids, and many of these kids aspire to one day work in the game industry, making a game design class an important step in their careers. Studies have also shown that using game design as a form of learning can be highly effective. We'll cover the computational thinking in a little bit, but first I'd like to introduce you to Studio K. Studio K began as an after-school program to teach basic game design principles to middle and high school students using Microsoft Kodoo. The curriculum is designed to teach basic game design principles using the acronym GRASPS, which I will get into in just a few minutes. However, this past year we have worked to expand this curriculum into formal classroom spaces, and it is now in an online portal where students can browse other students' work and upload their own. So what's Kodoo? Well, Kodoo is a visually based game design tool developed by Microsoft Research. It's used all over the world and allows students to quickly create their own 3D games. There is no traditional scripting involved. Instead, actions and behaviors are coded using tiles like the ones in the bottom image. With these tools, students can create an extremely wide variety of games across many different genres. So I mentioned GRASPS, but what is GRASPS? So let's think about some games. Basketball, Monopoly, Mario, poker. These are all games, right? But what are the common elements between these that allow us to call them games? Well, that's what GRASPS is for. So we have goals, right? There's always some way to win the game, some win condition. This gives us reason to play the game, a goal. Rules. Rules restrict what we can do in the game, and there's usually some penalty associated with breaking the rules. In basketball, if you walk without dribbling the ball, that's called traveling, and the other team gets the ball. That's the penalty. So that's a rule that you have to follow in basketball. Assets. Games are all made up of stuff, and that stuff can be trees or blocks or coins or cards or basketball hoops and basketballs. But most games are made up of some collection of objects, and this is what we call assets. Spaces. Games have to take place somewhere in some space. A basketball court, a square-shaped board with properties to buy and trade, Mushroom Kingdom, a table in a room with poker chips. Students must learn how to design the spaces of the games to affect the player experience. Play mechanics. These are the verbs of the game, the action words. They are the things that players can do. They can run, jump, shoot, pass, buy, sell, collect, or bluff. Those are all things that can be done in different games. So the play mechanics interact with the rules of a game to produce meaningful actions within the context of the game. Scoring systems. While not all games have scoring systems, they are often incorporated as a way to provide player feedback and notice of progress. Generally, the more points you have, the better you're doing. Golf is an obvious example of the opposite of that. You want as low of a score as possible. Scoring systems can also represent health, time, and currency, all of which can be traded or used in some way to a player's advantage. So that's GRASPS, and these 6 dimensions are things that we try to teach in our game design curriculum. From the perspective of the player experience, how can a designer change and manipulate these elements in their game to achieve a specific play experience? That is the question we are trying to get our students to answer.
I want to go ahead and give you guys an idea of how the Studio K curriculum works, how we've used it in courses so far, and how we plan to use it as part of this research here. The curriculum itself functions more like a framework where we actually have all of the computational thinking constructs and the game design constructs laid out in a series of missions. And one thing that's nice about the curriculum is it's designed so that the missions can be used in several different settings. It can be used in after-school clubs. It can be used in the classroom, in a game design classroom. It can also be modified and used in other classrooms. And we've really tried to structure it so that it's open-ended, so that the teacher can go in and add and subtract from the curriculum as necessary to fit the time constraints and other constraints that the teacher might have. So we've used this curriculum in a after-school club that has gone for longer than a year. We've also used it in a group of students that we only had for 40 minutes 4 times. So it's really flexible there. Basically, the structure of the mission looks like the following. You're going to have an introduction to the particular mission and game design construct. So in this case, we're looking at spaces here. We go through all of the game design constructs, goals, rules, assets, spaces, play mechanics, scoring systems, and then we also do a session on narrative as well. So we'll go through all of those items, and we actually provide introductory materials to it, and we want to have the ability to have links there for the teacher to find alternative resources for this as well. In each mission, then, we're going to have 3 activities that we call level 1, level 2, and level 3. The first of those levels is a play level, where the player is going to actually play some game or play some link, go to some link online and play some game, or play a Kodu level that is specifically designed to highlight the game design construct for that level. So in this case, the play mechanic or the game design construct is spaces, so the game would want to go towards that. Additionally, the level 2 then would be a similar thing where the student would play through a Kodu level, but there would be something intentionally broken in that level that we would have gone in as instructors and broken for the player to identify and then actually fix the problem that is causing you to not be able to advance in that game. Level 3 then is going to be where they actually do a creation challenge. So the student is actually going to be given some constraints, and they're going to start with a blank world and be able to create a challenge based on some of the constraints. So basically we have here, this is an example, the spaces one, so I've kind of shortened it for this session here, so the play and fix sections of level 1 and 2 are kind of combined here. But level 3 is a good example too, where sometimes they're creating things outside of Kodu. So this is a good example of something that can be done on a day when the network is down or Kodu is not available. Also an assignment that can be done at home when Kodu might not be available. So in this case, they're making a paper prototype of the maze. And it's important that we mix these kind of these kinds of challenges in as well, because it gets students thinking about how the game constructs that they're learning about apply to Kodu, but also outside of the game. Another section that we don't have on here would actually be an opportunity for the player to do a boss fight, and the teacher can enable or disable these particular parts of the mission, but the boss fights would be an expanded set of creation challenges that would take advantage of something that they might not have learned yet in this mission, or some particularly difficult challenge that we would hope them to be able to accomplish. So basically then when they complete each of the challenges in the mission, they'd be graded based on one of these a rubric similar to the one displayed here. Now these are kind of our version 1.0 or 2.0 of these rubrics, and we're still researching how to effectively have the teachers assess these games, but this gives a good idea. In this particular example, we're looking at the complexity of the code and the script of the game, as well as some of the visual and design elements of the game. We also want teachers to recognize here where they and the players to recognize that the games can fit into some of the genres that are specific to learning content areas, so we give credit for that as well. What's nice though is when you get this curriculum, basically we want to be able to provide the teacher with these particular challenges and these missions and lay them out the way that they were. We were kind of looking at how the lesson plan setup can happen, so the teacher can take the mission, and we give notes on how much time it should take, and we'd hope the website that could provide that additional information as well. We're going to provide cheat sheets for the teacher on what to look for, how to use the rubrics, and then also links of places to find more information online. And they really want to provide them in this curriculum with assessment tools, so like the rubrics and additional tools that we can use to assess how the students are doing and how they're progressing in it. This kind of all culminates in the Studio K website, which is pretty important because if you notice on the rubric, this is a copy of the paper version of the rubric, and if you notice, we have example screenshots from some of the challenge solutions here, some of the things that would exemplify fixing their particular problem or creating something that addresses one of the challenges. But even with screenshots, you really don't get at exactly everything that the mission is asking for. So that's why we envision sort of a interactive website. The Studio K website would come in and serve as the online community for this information. It'd provide the teachers with more developed resources for evaluating the students' games, and basically a place for them to work with the students' games, a place to grade the students' games, and then also the learning analytics portion of Studio K, which would allow the teacher to see not only what the students are doing, but also how they're progressing through some of the computational thinking skills that we're also trying to impart in this curriculum. And that's something that we really want to dive into more deeply once we're moving forward with the research as well.
So before we talk about any of the learning analytics or the research side of this project, I want to first orient everyone to the website in general. So we imagine this website to be an online community both for teachers and students. This will primarily occur within the forum area. So students will be able to use the forums to ask each other questions about how to do certain things within Kodu. Additionally, they'll be able to go through and view each other's levels and review those and rate those. So it's a way for them to get information from their peers about what can be done within Kodu. Additionally, teachers will be able to use the resource as a way to share different ways to implement Kodu within their classrooms. We designed a curriculum that focuses primarily on game design. We have a few missions that have levels within them that ask students to think about other core content such as math or literacy, but we don't have anything specific or a thread going through all of those. So the forums for the teachers will be a great way for them to share how they've applied Kodu and game design to their core curriculum. Additionally, we want teachers to have a really easy way to look at all of the levels and the work that their students are doing within the curriculum. So we will provide work and grade books for them online, very easy to access and to examine all of the work that is being done. Additionally, since we know that not all teachers are as technologically advanced, we are providing learning analytics that will help teachers better assess the games that are being created, and then additionally they'll be able to look at the computational thinking constructs that we think are important, and it'll be very easily highlighted for the teachers to see. On this page you can see how the missions will appear to a student. So the student will go through and play a level and then complete 3 tasks, and the teacher has an option of creating a boss fight as well as a final end task or test for the student. This page is the teacher's view of the student studio page, and this is really helpful for teachers to see how a student is doing in the curriculum and to track different behaviors as they work through the curriculum. So for example, you will be able to see the different achievements that a student has gained through the levels and the missions. You'll be able to see the levels that a student has created within the gallery. On the bottom you can see an activity or newsfeed, and this will be really useful for teachers to track activity within the community. So it will show events that the student has completed, things like assessing another student, doing a self-assessment, reviewing a game for another student, and submitting levels for missions. At the top part you can see some analytics. The top graph shows an event stream from a student's design process. This will be live streaming so that the teacher can go and view different students within the classroom and see how their progress is going within Kodu itself. So this is coming directly from Kodu, and it shows the different events that the student has done while they are programming and designing the level. And this will be really helpful for teachers to see whether or not their students are on task. For example, within the clubs, I've noticed that a lot of students get caught up designing their own levels, and they get, rather than focusing on programming, they focus more heavily on, is the environment at the right state, the aesthetically pleasing state that they want. And if you are on a tight time schedule, this isn't the best thing, because you can get to the end of a class period and not have a successful game that's running. So this will be a way for teachers to look at this event stream and see really clearly that the student is caught up in this design process rather than focusing on programming. So that's one way a student or a teacher can use one of these graphs. Additionally, the second graph shows just general progress for the student throughout the levels and the missions. Teachers will be able to review students' games, and one of the things that we want to focus on is having students self-assess their own games. And this is great for just self-reflection and thinking back about the progress throughout the curriculum. And it's also a way for teachers to have to grade less. So it cuts down on the amount of work that they have to do, because we'll randomly assign the performance reviews to the students. They'll complete them, and then the teacher will only have to grade the levels associated with those performance reviews that will happen randomly throughout the curriculum. And the teacher and the student performance reviews are identical. And the only other thing is that the teacher receives, once more, these learning analytics that show what the student has been doing within each of the games. So you can see the same event map at the bottom as was on the previous page. And in this one, we highlight different computational thinking constructs that we have seen within the process. So it will really easily show the teacher what the students have been doing computationally, and then it has the clear examples of it within the graph. So it's really easy for teachers to see whether or not their students are getting the different concepts that we think they should from each of the levels and missions. This is a more general look at the classroom that a teacher can see. So you can toggle between classrooms and then see for each student what progress they're making within the missions, so what level they are currently on and what missions they've completed overall. Additionally, just to make it really easy for teachers, we provided a pop-out performance review so that they're able to see the Kodu application and the assessments at the same time. And this is just, once again, to make sure that the teachers have the best experience using Studio K that they can. We really want these tools to be successful and useful for them, and I think this is one of the ways that we are trying to do that. So using this website is great for teachers, but we also are using it on the research side as well as a way to track progress throughout the curriculum. So on the research side, we're really interested in collecting pre- and post-test interviews and surveys for all of the students who are using Studio K. And this will ask questions about interest and motivation to become game developers and game designers. And additionally, it will track knowledge. So we'll have questions about game design and then computational thinking as well, just to see whether or not the curriculum was a successful intervention. Additionally, we'll be collecting game artifacts throughout the curriculum, so we'll be able to track progress a student makes as they finish the different missions, and we'll be able to look at the quality of those games across the curriculum. We'll also track website activity. As I mentioned earlier, we want to create an online community, and we want to see how students and teachers are able to use Studio K to help facilitate teaching and learning game design and computational thinking. So we'll be looking at things like forum posts and game reviews and game ratings. Additionally, we'll be capturing screen recordings during game design for students, and this will just help us see what students are thinking about. We'll be capturing the audio for those as well, so as students talk aloud through their game design, we'll be able to capture that, and additionally we'll be able to see what they're doing within the game as they go through and design their environment and program their game. And finally, we're going to be collecting telemetry data so that we can map events that are occurring within game design and see with really specific minute detail what is actually occurring within the game design process for each of the students in each of the levels. And we'll be collecting this data through different clubs and classrooms, as we mentioned previously. And the reason why we want to look at this data is because we think that Studio K will be really influential in having students learn computational thinking. So Seymour Papert first coined the term computational thinking in 1996, and since then it's been a topic of interest for budding STEM communities. And as Wing defines it, computational thinking is taking an approach to solving problems, designing systems, and understanding human behavior that draws on concepts fundamental to computing. And Wing dealt a lot with abstraction and automation as the different constructs that were most important for computational thinking. However, there are many other practices of computational thinking in addition to those, and the ones listed above are examples of computational thinking constructs that we've been able to highlight through the game design process in Kodu. So either through the final product or the actual design process itself, we're able to find things like conditional logic, debugging, variables, algorithm design, and simulation. And right now, we're currently looking for additional constructs to capture within Kodu, and this will occur either through observing the design process, examining the event streams, analyzing discussion around games and design, and other areas related to the curriculum. And just to show you what this process looks like, this is one of the event maps that was created for a student within one of our clubs. Just to orient you with the graph itself, you can see time is on the x-axis, and it's a really short amount of time, just a few seconds, but on the y-axis is the different activity that is occurring within the design process. So when a student designs a game, they can be in 4 general design areas. So they can be playing the game, they can be programming the game, they can be actually designing the environment, or they can be paused, basically, if they're inactive within the game. So if they're in one of the main menus, or if they just haven't been doing anything within Kodu for a certain amount of time, then that appears as a pause as well. So in this stream, most of what's happening in the first 3 quarters is all dealing with design. There's some programming, but as you can see, the dot at the far right that is highlighted in red, that's when the student has actually programmed and set a line of code that he or she kept within the level later. So in this case, the student has programmed that the main character sees in first-person view. And as you can see right after that, the student jumps right into play to test whether or not that was coded correctly. And in this situation, the student has done it correctly. But in other situations, you can imagine if the student has programmed it incorrectly, he or she goes into play, and then the character's not in first person. What they'll need to do is go back to programming of that character and see what they did wrong. And then after they remedy that problem, then they'll go back to play to make sure that they did it correctly. And you can imagine if a student has continually programmed something incorrectly, they'll keep testing out the programming that they've done and continually making changes. So you'll see this emerging zigzagging pattern between programming and play until the solution is finally determined. And this is one of the computational thinking patterns called debugging, and this is one way that we're able to look at the constructs within the event mapping. So right now we're going through and trying to find other patterns like that show computational thinking through game design. But more broadly, Kodu and Studio K applies to STEM and arts. And STEM is one of the hot topics. We're really trying to encourage scientific and mathematical thinking within students, especially within girls. But we think that Kodu is a great way to, first of all, think about technology and programming, but also to apply other STEM concepts, but look at it in a more engaging way. So for example, as you can see in the pictures, teachers can try to teach mathematical concepts like area and length and width through Kodu, and you can think about the way that the space is designed within a game to elicit understanding of these concepts. So this is one of the ways that a teacher has used Kodu within their own classroom. And some of our own levels within the missions do look at some of these concepts. So within one, we ask students to try to teach either a scientific or mathematical concept to a student without explicitly stating anything. So for example, you can build a fraction game to try to teach your player how to think about fractions, and it'll be a more engaging way to think about those concepts. Additionally, we want to capture the arts and social sciences as well. And the art aspect comes pretty easily through the design process within Kodu. So it's really easy to make complex environments, and we hope that this draws in less scientifically minded students and get them comfortable with programming and STEM in a really kind of friendly, non-threatening way. And additionally, Kodu can be applied to other core curriculum like English and other soft sciences as well. So in order to understand how these processes are occurring, we need to get our curriculum within schools and have kids interact with it. So this summer we are planning 6 weeks of camp. These will be with students from 5th through 9th grade, and there'll be programs related to the university. And additionally, in the fall, we're moving towards implementing our curriculum within classrooms as well. So we'll have game design and computer science teachers using the curriculum, and hopefully some core teachers as well, just to see how it's implemented within those classrooms. And additionally, we'll be running about 2 to 4 after-school clubs in different areas near Madison, Wisconsin, just to see how the differences between students learning in a formal and informal setting, how those appear through the products that are made within the curriculum. And we're doing this so that we can understand generally how students think about computational thinking and how they're able to learn it. We want to see whether or not this method of teaching it provides the same educational benefits as a conventional classroom. Additionally, we want to see how teachers are able to use these tools that we're providing and whether it inspires more or increased teacher confidence in the material. Additionally, just as a personal note, I'm very interested in how this tool can be used to foster communities of girl gamers and girl game developers, just because the computer science field is pretty heavily weighted towards males. So I want to see whether or not this will provide a way for girls to get more engaged within this content. Additionally, I just want to say that if any of you are interested in either getting the curriculum set up in your own classroom, or if you just want to talk about computational thinking or the way that we're using the learning analytics or telemetry data, feel free to email anyone on this list. We're all very welcome to any questions. So thank you for your time, and I hope you enjoyed the presentation.